Hello, 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 and welcome back, my friends. We are nearing the end of our exploration of technology. I congratulate you all for making it this far. And we're very, very close to the end of the quarter here, so hang tight. This week is our last assignment. So if you're missing anything from this class, please, please, please take the time to get it done, get it into me. Don't put it on until the last week and make your life miserable, make my life miserable by making me grade it that late. Turn it all in, and then next week we'll just have a quick survey to kind of figure out how this quarter went, and we will be done. Woo! So, once again, we are still holding live Zoom meetings. Please, please come to them. We can hang out and play some games of skill after we talk about technology. So, you're all welcome. Please, please come. All right, we're doing one final unit this week. Really short. We're going to take a look at flight. So if we were still in school, we'd be making boomerangs right about now. Can't do that, unfortunately. So we'll do the next best thing. We'll make some paper airplanes at home, and we'll talk about what makes them go-go. So you should be able to identify some primary principles of man-made flight by the end of this lecture. And you're going to take some time this week to actually test them out and see how it goes. That's the idea. Let's dive right in. We'll just talk about those principles real quick. We'll take a look at the assignment, and then I'll let you go. I know you all want to go outside. It's really, really nice out there. I don't blame you. Let's do it. Okay, how do we fly? Well, there are a series of forces that act on a body that's in flight, and we really are just trying to maximize some of those forces to kind of overpower the others, and that's how we get from place to place. So here's a very really basic diagram that kind of demonstrates what we're dealing with here. You have thrust, which is pulling you forward, and is a force, so you need this to be larger than your drag. Drag is a force that's pulling you backwards. So planes go at about 600-ish miles an hour, so they have a lot of thrust, and the drag is all the wind resistance pushing against them, so they need to overwrite that. The lift is what's keeping you up, and it needs to counteract your weight. If weight and lift are equal, then the body is hovering in midair, not moving up or down. If the weight is greater than the lift, then you're going to plummet. And likewise, if your lift is greater, you're going to rise up. So the trick here is to manage all of these. And for a long time, we couldn't really come up with a model that would do all those things for us. Now, something interesting to consider is how do we do that? Well, a big trick that planes use is this idea of Bernoulli Principle. So Mr. Bernoulli here, he is a 17th or 18th century mathematician from Switzerland. He came up with a lot of statistical analyses and interesting math, which you guys should learn about, but is irrelevant to this class. But one thing he did come up with that's very relevant is this Bernoulli equation. And the idea is that if you make something go really fast, you will get less pressure. And this applies to all sorts of fluids, and you'll talk about this in physics, I'm sure. But in our case, we're going to be looking at air as a fluid. And you might say, well, air is a gas, Mr. M, you're silly. But in this case, it acts like a fluid, in that as you look at an airplane wing, and this is a cross-section of an airplane wing. So this is the top part, this is the bottom. You guys would be seated somewhere back there, and the wing's kind of coming out of the screen towards you here. The reason that the wing is this shape, this funky, we call it a foil shape, is exactly to take advantage of this Bernoulli's principle idea. So as you have air flowing, it's flowing at the same rate all across here. Remember, we're moving this way pretty fast, so this air is moving past us pretty fast. If we have the wing angled at such an angle right here, the air over here is going to move the same speed pretty slowly, and it's going to have higher pressure. It's going to retain whatever pressure it had earlier. By making the air go slightly faster up here through the use of this shape, it has a longer distance to travel here, and therefore needs to go faster. So what ends up happening is you actually create some lift just through the use of this clever shape. So that's an interesting tidbit there for you about how real airplanes work. Now, what are you guys going to do for me? You're going to be completing a flight activity, and you're going to kind of research a couple of these ideas. So we're going to look at a video that talks about these four forces we just talked about. We're going to talk about some things I didn't cover, but also airfoil, which is that shape we just looked at, Bernoulli's principle. And then you guys are going to do some tests on your own. So I'd like you to make two different kinds of paper airplanes and then go out and fly them. And the idea is we just want to see what you think works best as far as paper airplane goes. If you don't have a camera, I do ask for pictures. Please let me know. We can work something out. So just send me an email. Hey, Mr. M, I don't have a camera. For distance, if you don't have a tape measure, just try to eyeball it. Use your body. You know how tall you are roughly. How many body lengths did it fly? And you can approximate as close as you can, right? As long as we know which one's flying better, that's really all that's important, right? All right, that pretty much covers it for me. So hopefully you guys have some fun building these airplanes. Hopefully we see some really cool designs. Please shoot me an email if you have questions with any of this information or have an issue of any kind. And I hope to have you guys all pass my class. If you're not currently passing, please, please, please make an effort. I will still take any late work. I'm happy to work with you, but you got to reach out to me. All right? Okay, have a good one and enjoy the nice weather. Take it easy.